The Piper Aircraft Corporation and the Piper Training Center presents a mechanics orientation on the operation of the landing gear systems. The landing gear system is basically the same on the Piper Arrow and Turbo Arrow 4 and on the Piper Lance and Turbo Lance 2 and the Saratoga SP. For the ease of explanation, we are going to divide the landing gear system into two sections, Section 1 hydraulics and Section 2 electrical. Let's take a look and see what components make up the hydraulic system and where they are located on the PA-28R and the PA-32R. The hydraulic pump, the source of power for the gear, is located behind the rear cabin bulkhead on the Arrow. In the Lance, the pump is in the front baggage compartment, as seen here through the access panel. From the pump, hydraulic pressure is directed to the actuating cylinders located in the wheel wells. Here we see the left main gear actuating cylinder on a PA-32R. Incorporated in the system is a gear backup extender actuator or auto gear extender. In the PA-28R, the auto gear extender is located under the rear seat as seen here. The auto gear extender in the PA-32R is located under the center seats and floorboard in the center section of the plane. In conjunction with the auto gear extender is the mast, which is located on the left side of the fuselage on both aircraft. The last component in the hydraulic system is the pressure switch. On the PA-28R, the pressure switch is located under the rear seats. In the PA-32R, the pressure switch is located in the gear-up line right at the base of the power pack. Those are the components. Now let's see how they operate. Starting with the power pack, let's select Gear Up. Here we see the gears of the hydraulic pump. When we select Gear Up, the top gear turns clockwise and the bottom gear turns counterclockwise, pulling the hydraulic fluid from the reservoir down through the check ball and around the gears. The check ball shown here prevents the hydraulic fluid from going back into the reservoir. Our fluid pressure then goes up through this line and meets the high-pressure relief valve. The high-pressure relief valve prevents the system from reaching too high a pressure that would harm the system during operation. On the Arrow and Lance, the high-pressure valve is set at 2,000 to 2,500 psi. Knowing that the hydraulic fluid will take the path of least resistance, let's see what happens. Fluid flows down to the gear down shuttle pin, pushing it over and flowing through the gear up check valve. Fluid goes in two directions from here. It goes out of the power pack to the rest of the hydraulic system, but it also goes to the thermal relief valve. The purpose of the thermal relief valve is to protect the gear up side of the hydraulic system from excessive pressure due to thermal expansion. The thermal relief valve on both aircraft is set to release the pressure on the system at 2,250 plus or minus 250 psi. The fluid leaving the power pack flows out to the actuating cylinders and to the auto gear extender. The unique feature about the landing gear system used in the Piper single-engine retractables is the automatic gear extender. Gear-up landings are usually prevented by this Piper feature. When airspeed drops below a predetermined speed, the gear is automatically lowered, preventing aircraft damage. Let's take a look and see how this all takes place. Here we see a diagram of the auto gear extender with the mast. The auto gear extender operates by a valve connected to a diaphragm. The diaphragm is encased in a housing with one side referenced to ram air by a line connected to the mast, and the other side of the diaphragm is referenced to static air by a line connected to the same mast. As the aircraft reaches a predetermined speed, the valve will completely close, allowing the hydraulic fluid to build up pressure and retract the gear. Likewise, when the plane drops below the predetermined speed, the pressure on the diaphragm will decrease and start to open the valve and allow the hydraulic pressure that is holding the gear up to drop and the gear will free fall into the down position. This adjustment screw adjusts the spring tension on the backup extender control arm, thus changing the airspeed at which the unit operates. Clockwise rotation of the screw tightens the springs and raises the airspeed at which the valve closes. Counterclockwise rotation of the screw loosens the spring tension and lowers the airspeed. The predetermined airspeed settings for the auto gear extender may be found in the Piper service manuals for these models. The auto gear extender does have an override feature. In the cabin between the pilot and co-pilot seats, there is a lever in each plane. The lever is attached to the valve on the auto gear extender and has two selections. In override, the valve in the auto gear extender is closed, allowing no hydraulic fluid to escape regardless of the speed the plane is moving, eliminating the auto gear extender completely. The use of the override is good for short field takeoffs, allowing the pilot to retract the gear below the predetermined retraction speed, thus cleaning the aircraft up for better performance. Also, during training exercises, like stalls, the gear is prevented from free falling at slower speeds. The other selection of the lever is the emergency gear extension position. When the emergency gear extension position is selected, the valve on the auto extender moves to the full open position, releasing all hydraulic pressure on the gear up side, and the gear free falls to the down and locked position. Emergency gear extension is used in the case of gear malfunction. Let's take a look at the Turbo Arrow 4 representing the PA-28R series and the Turbo Lance 2 for the PA-32Rs to see just what the emergency override lever looks like. Looking in the Turbo Arrow 4 between the pilot and the co-pilot seats, we see the lever painted red. To put the gear in override, the pilot must pull the lever up and push the locking pin in to hold the lever up. But remember, when the lever is in the override position, the gear will not come down automatically. With the gear in override, a blinking yellow light on the instrument panel will tell the pilot the system is in override. To use the emergency gear extension, the pilot must push the red lever down. In the Turbo Lance 2, the red lever is also between the seats, but this time it's on the other side of the trim wheel. Also, instead of having a pin to lock the lever into override, press this tab down to hold the lever in the override position. Just like in the Arrow and Turbo Arrow 4, the Lance and Turbo Lance 2 also have a yellow warning light on the instrument panel. To use the emergency gear extension, press the lever down. Once we reach the predetermined speed, the auto gear extender allows the system to build up pressure, and the actuating cylinder then retracts the gear. After all three gears are up, the hydraulic fluid builds up pressure. When the pressure reaches a predetermined setting, the pressure switch cuts off electrical power going to the hydraulic pump. The pressure switch on the Arrow and the Lance is set at 1800 psi. There are no adjustments on the pressure switch. Once the pump stops, the gear up check valve closes, trapping all the hydraulic fluid and pressure in the gear up lines. The trapped pressure in the lines is how the gear is held up. Now we know what happens with the hydraulic portion of the gear when we select gear up, but what happens when we select gear down? Starting with the gears in the hydraulic pump, let's select gear down. This time the gears rotate in the opposite direction. The top gear rotates counterclockwise, and the bottom gear rotates clockwise, drawing the check ball off its seat and allowing hydraulic fluid to enter the system from the reservoir. The gears pull the hydraulic fluid through, down to the gear down shuttle pin, pushing the gear down shuttle pin over to the right. When the gear down shuttle pin slides over, it pushes the gear up check valve off its seat. Now the check ball closes here, and the hydraulic fluid used to lower the gear is taken from the gear up side, or we should say the return lines from the actuating cylinders during gear down operation. From here, our fluid flows to the low pressure control. The low pressure control opens, allowing hydraulic fluid to flow into the reservoir. In the case, hydraulic fluid was unable to flow out of the power pack. The low pressure control is set at 650 plus or minus 150 psi on both the Arrow and the Lance. Flowing down to the shuttle valve, Hydraulic pressure pushes it over and fluid flows to the actuating cylinders and extend the gear to the down and locked position. Here in our diagram, the two restrictor fittings on the main gear cylinders are installed in both the Turbo Arrow 4 and Turbo Lance 2 and are located on the gear up side to slow the speed the main gear moves in both directions. This concludes the hydraulic section of the landing gear system on the Arrow and the Lance. The electrical portion of the landing gear system is the same for both the PA-28R and the PA-32R aircraft. We are going to use a diagram to demonstrate what takes place with the electrical system during gear operation. Here we see the electrical diagram as it would be with the plane setting on the ground. Knowing that when the plane is on the ground, or should we say the gear down and locked, we should have 3 green lights on the instrument panel. To operate the lights, we must have power and a ground. If we follow the 3 wires from the lights to the down lock switches, we see they get their power from the bus bar through a 5-amp circuit breaker. Now all we need is a ground. The wires leading to the down lock switches supply the power, so the other wires connected to the lights must be the ground. Here we see the wire runs over to the nav light switch, and when the nav lights are not on, the down lights go right to ground. But when you turn the nav lights on, the down lights must seek a new ground, and they do by going through this resistor to ground. The resistor dims the lights for night operation. To prevent the gear from retracting on the ground, we have a squat switch on the left main gear as shown here on the Turbo Arrow 4. In the diagram, we see that power runs to the squat switch from the bus bar through a 5-amp circuit breaker. On the ground, the squat switch sends current to the gear selector switch, and if we would select gear up on the ground, the power would run down this wire to the gear unsafe light, telling the pilot the gear is unsafe and the selector is in the gear up position. Simple. Now let's take to the air. As the plane lifts off, the squat switch will switch over, now sending the power to the slow flight switch. The location of the slow flight switch is on the auto gear extender. When the auto gear extender will not allow the gear to retract, it opens the slow flight switch and turns on the gear unsafe lights. It prevents power from running to the hydraulic pump up relay, preventing the pump from running. But when the airplane reaches its predetermined speed, the auto gear extender closes the slow flight switch and allows power to run to the hydraulic pump up relay. Now we have power applied to the hydraulic pump up relay, but to activate the relay we must find a ground. Follow the ground wire. It goes to the gear selector switch. Having just taken off, we are ready to retract the gear. Pull the selector switch out in the Arrow 4 and move it to the gear up position. When we move the selector to the gear up position, we provide a ground for the hydraulic pump gear up relay, and the relay closes. At all times, we have bus power running to the hydraulic pump up and down relays through a 25-amp circuit breaker. After selecting up, the hydraulic pump begins to run and the gear starts up. The down lock switches open and put out the indicator lights in the cockpit. Looking at our diagram, we see that when the down lock switches move over, the green lights go out, and now power is directed down the 3 wires and join here. From here the system supplies power to the gear up limit switches. Power also travels to the throttle switch and the hydraulic pump down relay. Power being supplied to the up limit switches on the nose gear of the Arrow and here on the main gear travels through the up limit switches and lights the gear unsafe light. The gear continues to retract, and once the gear reaches its full up position, the up limit switches move over, shutting off the gear unsafe light. If any one of the 3 gears fail to retract, the red unsafe light will not go out. The gear is up, but the pump is still running. In our diagram is a pressure switch. Its location was shown in section 1. Remember, in the Turbo Arrow 4, it was located under the rear seats, and in the Turbo Lance 2, it's located in the gear-up hydraulic line just as the line is leaving the power pack. Once the hydraulic system has reached a predetermined pressure, the pressure switch opens, cutting off power to the hydraulic up relay, shutting off the pump. If the hydraulic system would happen to have a leak, as soon as the pressure went down, the pressure switch would close, turning on the hydraulic pump until the pressure builds back up. Looking at the bottom of our diagram, we see the gear warning horn. The horn is located under the instrument panel. The horn is installed in both planes to warn the pilot that he does not have gear down should he forget before landing. The horn is wired to the throttle switch, and any time the throttle is pulled back below 15 inches manifold pressure, the throttle switch switches over, sending power to the horn and to the gear unsafe light. When we push to put the gear down, power is already supplied to the gear down relay. So, when you move the gear selector to the down position, it provides a ground for the relay, and the relay closes, turning on the hydraulic pump, and the gear extends. The hydraulic pump is shut off once the gear is down and locked by the down lock switches. Once all three switches move over, they cut off all power to the hydraulic pump down relay. The last item on our diagram is the override light circuit. When you select override, you provide a ground through a flasher for the yellow override light. The preceding has been a review of the landing gear systems on the Arrow and Lance aircraft. Further information pertaining to the landing gear system may be found in the appropriate service manual, bulletins, and service letters. This program was produced for training purposes only and is not intended nor capable of replacing the appropriate service publications.